Okay, today's lesson is on the double angle formula. This PowerPoint is on double angle and half angle, and this is page 18 in your logbook. We're only going to look at the double angle today, so we'll do half of this PowerPoint in this video, and then the half angle formulas we'll do in another video. So, our objectives for today, we're going to do the first two objectives for today. We're going to use the double angle formula to find the exact values, and we're going to use the double angle formulas to establish identities. You know how to establish identities, so once we learn the double angle formulas, you'll add those to your repertoire of formulas that you can use to establish your identities. Alright, these are your double angle formulas. If you'll look with me, you see that the angle theta, the argument, okay, this theta has been doubled. So our argument is 2 theta. So we're looking at the sine of 2 theta, and the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And this is a formula that you have to know, and we're going to establish this formula in just a couple of minutes. The cosine of 2 theta is equal to the cosine squared of theta minus the sine squared of theta. I always remember this one because it looks a lot like the Pythagorean identity, but it's a minus instead of a plus. So it's the cosine of 2 theta equals the cosine squared of theta minus the sine squared of theta. A second formula for the cosine of 2 theta is 1 minus 2 sine squared theta, and cosine of 2 theta is equal to 2 cosine squared theta minus 1. You're going to have to be familiar with all of these formulas. Okay, so what we're going to do first is derive the formulas for the sine of 2 theta and the cosine of 2 theta. Go ahead. No, you're fine. Okay, these are derived from the sum formulas that we used yesterday. So the first thing that I want you to do is look at the sum formula from yesterday for the sine. So the sine of alpha plus beta is equal to, and hopefully you remember, since it's sine, we're going to use both of our trig functions, sine of alpha, cosine of beta, same sign, so plus the cosine of alpha. Let's see if I'm moving this so you can see it, and the sine of beta. Okay, you should already know that formula, and if you don't, you need to go back and study it and make sure you know it. It should be on your graphic organizer. Alright, so what we're going to do is we're going to say, well, what would happen if we let alpha and beta be exactly the same angle? So instead of two different angles, alpha and beta, I'm going to say let alpha and beta be equal to each other. So I'm going to call those angles now theta. So now I have the sine of theta plus theta, which is the sine of 2 theta. So what we're going to do now is everywhere in our sum formula that we see an alpha or a beta, we're going to insert our theta. So what we're doing is deriving sine of theta. Okay? And now, hopefully you know from the commutative property of multiplication that the sine of theta times the cosine of theta is the same as the cosine of theta times the sine of theta. Okay, so that's going to give me, this is an understood 1 in the front, an understood 1 in the front. So when I add these two together, that's 2 sine of theta, cosine of theta. Okay, so now we have derived that first formula for the sine of 2 theta. Okay. We can also derive the cosine of 2 theta. Let me slide this up just a little bit. We're going to start again from our formula for the sum that we learned yesterday. The cosine of alpha plus the cosine of beta is equal to the cosine of alpha times the cosine of beta. Hopefully you remember that this is cosine, cosine, opposite sine, sine, sine. So the cosine of alpha times the cosine of beta, opposite sine, sine of alpha, sine of beta. And once again, if we let alpha and beta be the exact same angle, then we can replace our alpha and our beta everywhere that we see one in our formula. So the cosine of theta minus the sine of theta and the sine of theta. Well, hopefully you can see very quickly that theta plus theta is 2 theta, and cosine times cosine is cosine squared, minus sine times sine is sine squared. So now we have derived from our sum formulas the cosine of 2 theta. Now, like we talked about in class before, an application of the Pythagorean theorem, sine squared plus cosine squared equals 1, results in 2 other ways to write the formulas for the cosine of 2 theta. We can take this formula for the cosine of 2 theta and I can replace the cosine squared with 1 minus the sine squared, right here. That cosine squared is 1 minus the sine squared, and so negative sine squared plus negative sine squared is negative 2 sine squared. So this is the second form of the same formula. And then I can do the same thing with the cosine of 2 theta. I'm going to replace the sine squared with 1 minus the cosine squared, and that gives me cosine plus cosine, because when I distribute this negative to this negative, it gives me a positive. So that's where the 2 cosine theta minus 1 comes from. Okay, now let's look at an example. So let me move this so that you can have a fresh sheet to look at. It says if the sine of theta is 5/13, and we know that theta is between pi over 2 and pi, we have to find the exact value of, first, the exact value of the sine of 2 theta. Okay? All right, so, and then we're going to come back and find the cosine of 2 theta. So the first thing you want to know is what quadrant is theta in. Theta is in quadrant, and look right here with me if you will. This says that theta is between pi over 2 and pi. So pi over 2 and pi, here's pi over 2 right here. Here's pi right here, so that's quadrant 2. That's in quadrant 2. So I'm going to go ahead and just draw my triangle like I always do in quadrant 2. Drop the perpendicular down, and I know that the sine of theta is y over r. So my y right here is 5, my r here is 13, and I used Pythagorean theorem to find my x. So x squared plus y squared equals r squared, plugging in my y and my r, and finding out that x is 12, and it had to be negative because we were in quadrant 2. So I know the cosine of theta. I'm gonna go ahead and just put it right up here with this one. So the cosine of theta is negative 12 over 13, because that's x over r. Okay? So I know the sine of theta is 5 over 13, the cosine is 12 over 13, and now all I have to do is use my formula. So the sine of 2 theta, let me scoot over, is equal to 2 times the sine of theta times the cosine of theta. And that's going to be 2 times the sine of theta is 5/13, and the cosine of theta is negative 12/13. And when I multiply, I can see that I get 5 times negative 12 times 2, that gives me negative 120, over 1 times 13, which is 169. So the sine of 2 theta is negative 120 over 169. Now you can look at the PowerPoint and see that we did the same thing for letter B, which was the cosine of 2 theta. So for letter B, turn that around, the cosine of 2 theta, that formula is the cosine squared of theta minus the sine squared of theta, and the cosine of theta is negative 12 over 13, so we're going to square that, minus the sine is 5 over 13, and we're going to square that. So that gives me 144 divided by 169 minus 25 divided by 169. And then 144 minus 25 is 119 over 169. So the cosine of 2 theta is 119. Oh, and I just messed that up. Sorry about that, guys. 144 minus 25 is 119, so the cosine of 2 theta is 119 over 169. Okay, very quickly we will derive the formula for the tangent of 2 theta. I'm going to go through this with you and let you look at it. We're using the same tactic that we did before. We're using the sum formula, so the tangent of alpha plus beta. Our sum formula for tangent is tangent of alpha plus tangent of beta over 1 minus the tangent of alpha times the tangent of beta. I'm replacing alpha and beta with the same angle so that I can say, well, that's 2 theta. And I'm replacing every alpha and beta with our thetas there. So 1 theta plus 1 theta is 2 theta, and I'm sorry, I said that wrong. Tangent of theta plus tangent of theta is 2 tangent of theta, and tangent squared comes from this tangent times this tangent. That's where this tangent squared came from. So here is your formula for the tangent of 2 theta. This is your double angle formula for tangent. Okay, so there it is. Double angle formula for tangent. Okay, there are other variations of the double angle formula using algebraic manipulation. So I want you to look through these, copy them down, discuss with your table partner, because you're doing this in class today, how these manipulations came to be. See what you can figure out, and when I get back to class, I will go over that with you. So pause the video and copy these, and then discuss with your table partner. Okay. Here's the second one I'd like for you to copy down, discuss it with your table partner, see if you can recognize the algebraic manipulations that we used here, and we'll discuss that in just a little bit. And here is the third one. So pause the video, copy this down, discuss it with your table partner. Okay, I'm sorry, I didn't mean to flip backwards. This is an identity that I want you to, again, establish. I'd like for you to look through this. One thing I want you to remember is this formula right here. If you don't remember this formula, I need you to go check it out on the internet. This is the sum of 2 cubes. This is an algebra. The sum of 2 cubes, and we are factoring that. You should have learned this in Algebra 2. So if you don't remember how to factor the sum of 2 cubes, look in the back of your textbook in the appendix. Find the factoring section and study up on that. Copy through this, pause this, copy through this identity, and then again, this is something that we kind of need to discuss together, so as long as you have it down in your logbook, we'll discuss it, but I need you to be sure that you have copied this down. Okay, pause the video, copy it down, flip back and forth to the pages, and get that taken care of. All right? Thanks, guys, and I'll see you in just a little bit.